for the introduction of problems. Now this is some conducting made up of iron, and there is some spherical cavities there. Are you looking at this one? Cavity means no material. Iron is present here, air is there. Here cavity, there's no iron material here. Spherical cavity of radius r. And look at the shape of iron body. It is some iron body. I'll write it. So it is some arbitrary shape. So what is the radius of curvature of outer surface will be different at different points. Now what I do is like, I'm going to keep a point charge exactly at the center of cavity. Try to read this condition. This is very important. Exactly at the center of cavity, a point charge is kept. Then what will happen? Then what will happen? We know what is the basic rule. The net field inside the conductor due to static charges must be 0. So and what is this? Basically, it's a neutral. I'll write. Initially, it was electrical neutral, no? Okay, so electrically neutral. Then, very beginning of electrostatics, like what we said, electrostatic induction will obey law of conservation of charge principle. Now also, what should happen to net charge of this iron body? Should be 0. Net charge of this iron body should be 0. But we have kept a point charge here, and net field inside the conductor must be 0. So let me choose a point P. Where is the red color? Red color is here. Red color. Let me, I need these colors. Arrows also need. Yeah. Yeah. So let me choose the point P here. Now what should be the net field inside the conductor due to static charge? What is the point P inside the conductor? What should be the field here? Should be 0. Okay, now this positive charge will produce a field here, no? In what direction? It will be directed. I'll show by red color that one due to the point charge. So this is how much it should be equal to EQ. Will produce this field, this particular point charge. Then, okay, let it be, sir. Then here what happened? Free electrons which are there will experience a force. Then they'll start moving in one specific direction. There'll be net flow of charge. Heat will be generated. Temperature of conductor will increase, and law of conservation will get violated. So what went wrong? So this field should not be there, no? But according to Coulomb's law, any charged body will produce a field. So this particular point charge will produce field here. But practically, if I go and check what is the temperature of this iron body, will remain constant. So therefore, it shows that the net field at point P must be 0. Then who is the field which will counterbalance this? Yes, for that purpose, this point charge will induce a negative charge on inner surface. Getting the idea? I am explaining the most beautiful part of electrostatics. Please do listen. So now a point charge is electrically neutral. What is the field strength at point P? In fact, it will be 0, no? And what is the state of electron, free electron? They'll be moving randomly. Getting this? Now, if a point charge Q is kept at center of cavity, it will produce a field. Then the free electrons which are here will move. Earlier they were moving randomly. They'll start moving in one specific direction. Then there'll be net flow of charge to any given surface. There'll be heat, current will flow. Heat will be generated. Temperature of iron body keeps on increases. Who is spending energy? No agent is there to supplying energy. Then how come the heat energy of this body will keep on increasing? So law of conservation of energy got violated. What went wrong? We are saying that the field is present. We are saying the net field is present. The net field should be 0. Then who will counterbalance this field? So for that purpose, here negative charge, this will induce a charge. What this point charge will do? It will induce negative. Will it induce negative charge everywhere, negative, positive? No, on the inner surface of cavity, it will induce negative charge. And what this negative charge induced will produce a field. So this I'll write it as EI. Getting no this one? So this is something very important. And the EQ, what is EQ? Charge produced by the point charge kept at center. What is EI? Induced electric field produced, or the induced field produced by the charge induced on outer surface. So how much is that induced charge? I don't know. So I'm going to write it as QI. Can we calculate? No, according to the law of conservation of energy, the net field at point P must be 0. If net field is 0, I'm going to ask you now, draw a Gaussian surface. What is this? It's a Gaussian surface. Now, what is the net field at point P? We know 0. So net flux should be 0. That's all, no? If E bar is 0, then flux should also be 0. If net flux is 0, net charge enclosed should be 0. So what is the net charge enclosed? Qin is equal to Qi plus Q. So Qin must be 0. If Qin 0, then what is Qi? Equal to minus Q. So what is the induced charge? How much it should be? What charge will be induced? Positive or negative charge? Negative charge has to be induced here. So why minus Qi? And how much magnitude? Equal to minus Q. Okay, got this. So why negative charge should be induced? For this purpose. Then we know this conductor is an electrically neutral, and the electrostatic induction obeys law of conservation of charge. What should be the net charge of this? Should be 0. Since minus Qi induced here, plus Qi will be induced here. So charge on outer surface here. How much net outside? Plus Qi. So what is Qi? Qi magnitude should be equal to Q. So if you keep a point charge plus Q, how much will be minus Q on inner surface plus Q on outer surface of the conductor? Will it be uniform? Yes, on inner surface, the charge distribution will be uniform. Outer surface depends on radius of curvature. So sigma 1, okay, regarding the radius of charge distribution, sigma 1 equal to sigma 2. I can't write sentence. I'm just explaining. And what about sigma 3 not equal to sigma 4? Look at this point, sigma 3 not equal to sigma 4. Charge distribution on inner surface of cavity depends upon its radius of curvature. Everywhere the radius is same. On outer surface depends on what? Purely on radius of curvature. Radius of curvature 3 and 4 is different. So therefore charge density is different. Fine. So if you keep a point charge plus Q, what you get? Minus Q on the inner surface plus Q on outer surface. This is the thing. So what is the conclusion? Note. Minus Q charge when a point charge plus Q is kept at center of cavity. I think I need a lot of space. Huh? Oh, I'll introduce one more page. Huh? Where we are. Let me adjust things. I'll adjust it. Yeah. Okay, yeah, we have enough space to write things, scribble. All these are theoretical ideas. Numericals will be very easy for you. Note when a point charge plus q at center of cavity, then minus q charge or negative charge, then we'll write it here. Minus q charge is induced on inner surface of cavity and plus q on outer surface of conductor. There's a very primary thing. Please do. This is very important. And what about the charge density? Charge density on outer surface depends on radius of curvature. Charge density depends on radius of curvature and also position of point charge. Later I'll conclude here. Okay, this is justified. How we can say, sir, here minus q and plus q. Why minus q? Because of Gauss law. Why the outer surface should have the plus q charge? Because the conductor iron body is electrically neutral. And what about charge density? At 1 and 2 they are different. So I'll write it here. Sigma 1 equal to sigma 2, sigma 3 not equal to sigma 4. So charge density on inner surface of cavity depends on position of point charge and also radius of curvature. Okay, let's take the next condition. A point charge plus q is not at center of cavity. Are you looking at this? Then what will happen? Yeah. So again, our point was here, no? This was the point P, what we took earlier. Now, when I just go back to the Coulomb's law, from Coulomb's law, if you earlier the point charge was here, no, if you move the point charge plus q near to point P, what will happen to field strength here? Should increase. So the field strength due to point charge q will increase. It should become more. It should become more. EQ dash, I'll write it. Then the field strength at point P will increase. This means definitely what will happen? More induced charge should come here. Because if the net field should become 0, if this EQ increases, then this should also increase. So what we get is like, even this will also increase. What was the color I took? Yeah, violet. Even this should also increase. Still the net field at point P must be 0. Any reason for that? Because the iron body. Okay, again, there's a basic condition. It must be 0. Then what is the necessary condition? EQ dash should be equal to EI dash. Then for for the field strength at point P, as the point charge Q is moved towards the so it's not at center of cavity, no, the field strength at point P due to point charge Q will increase. So due to induced charge will increase. So for that purpose, what this will do is this will induce more charge here. And here it will be less. Get this one? I'm showing you more charge. But okay, let's calculate how much here. I'm interested in that QI. Writing there. Let me write it. How much QI will be? So QI. So again QI should be equal to minus Q. Any reason for that? Because the flux will be 0. As field strength is 0, net flux should be 0. Net flux should be net enclosed charge by the Gaussian surface should be 0. Where is the Gaussian surface? There is a Gaussian surface. Getting the idea? This one. So therefore, the induced charge should be negative. Then what is a conductor? Conductor is electrically neutral. So what it does? So it will produce a more charge here. So how much net charge will be plus Qi? Again, what is Qi? Qi should be equal to mod of Q. Now look at the charge density. I'm interested in these points. What were the points we took? 1, 2, 3, 4, no? 1, 2, 3, 4. What happens? Sigma 1 dash not equal to sigma 2 dash. Sigma 3 dash greater than sigma 4 dash. Can we compare with the initial value? Sigma 3 will not change. What was earlier sigma 3 dash will become equal to sigma 3 only. There won't be change in them. What about sigma 1? Sigma 1 dash will be greater than sigma 1. Sigma 2 dash. So what is the conclusion we can make it? The field strength on the inner surface of cavity depends on what? Radius of curvature and also location of point charge inside the cavity. What about the charge distribution on outer surface of cavity? Depends only on radius of curvature independent of point charge. Able to understand? This what? If I go and check it practically, sigma 2 what's happened will be sigma 2 dash will be less than sigma 2. Sigma 1 dash should be greater than sigma 1. So why charge density got increased? Because the point charge is not at center of cavity. So what is the conclusion now? The charge density on inner surface of cavity depends on the shape of cavity and also location of point charge in the cavity. Charge distribution on outer surface of a conductor depends only on its radius of curvature, independent of point charge inside the cavity. Now, these are some conclusions which I had to make it. Okay, come for this. Here, what was the thing? Just we had some conclusion previously. After moving this point charge, what I came to know, this charge distribution will not change. Whereas here, it will change. Okay, agreed? This one, the condition. So this everything I'll minimize it. These are very good questions. Are there? You see the books, no? So many things they've asked on this data. So what is the conclusion we can make it? Note. The charge distribution on inner surface of cavity depends on shape of cavity and location of point charge inside the cavity. So similarly, the charge distribution on outer surface of iron body. Conductor, I would have written, no, again, you'll start imagine some other thing. Outer surface of depends only on okay, fine. So if you move point charge inside the cavity, what happened to charge distribution on outer surface will not change. On inner surface of cavity will change. Then what about the, see, finally, there's the one thing. How much of charge will be there? Total charge will be minus Q. If you keep plus Q, minus Q, plus Q. Getting this idea?